Hello everyone. Today we will learn distribution function technique, and using that technique we will solve a mathematical problem. Here define x is a continuous random variable with the PDF f of x is equal to 3x square for given x 0 to 1, and then find the PDF of y is equal to x square. Okay. So basically what is here asks that we have to find the PDF. As we already know that to find PDF, first of all we need to differentiate the CDF, right? So if we differentiate CDF, then we will find the PDF. We will find the PDF. For differentiating CDF, first we have to know what is the CDF. So we have to know what is CDF. So let's jump into it. First of all, we have to find CDF. How we can find CDF? CDF is defined as y, f of y, capital Y, as a subscript, y inside a function is equal to probability of capital Y less than small y. Now here capital Y is given is equal to x square, so we put x square here, and we can arrange it like this one. Okay, and if you notice that now we can write it like this one, f of capital X as a subscript, y to the power half. So basically if you notice this one here, the subscript changed. That is the distribution function technique is all about. Okay, next what we can do here, we have to integrate it. If we extract CDF 0 to, this is the upper limit, y up to half, and now we will put the PDF is defined here 3x square, so 3x square, and definitely it will be dx. Okay, now what we can write here is 3 is constant, so it will out of there, 0 to y to the power half x square dx. Okay, next what we can write, 3, if we integrate it, it will be like x to the power 3 divided by 3, and the limit will be 0 to y to the power half. This 3 and this 3 will be cancelled, so we will have y to the power 3 by 2 minus 0, and we will leave with y to the power 3 by 2. So what is actually this y to the power 3 by 2? It's nothing but our CDF. So the first observation to finding CDF is done. Now if we derive this CDF, we will find our appropriate PDF. So we will derive this CDF. So if you derive that, 3 by 2 y to the power 3 by 2 minus 1, 3 by 2 y to the power half, and it is actually our PDF of y. So using this distribution function technique, we successfully found our PDF of y is equal to x square. So what we done overall, basically, first of all as we have to find the PDF, we need a CDF very first. We need a CDF. So we calculate our CDF. We found it in here. After finding CDF, we derive this one, and find our desired PDF. So we found our PDF. Sorry. Okay. So that is it. That is how we can find solve this kind of a problem using distribution function technique. Thank you very much.